The first task is tinning the pads. Notice the placement of the solder and the direction in which the iron wipes. After all the pads have been tinned, the area is wiped with solvent. The bending is done with a lead forming tool or a pair of duck-billed pliers. The leads may need to be trimmed for a proper fit. In some circumstances, the specifications may require pre-tinning of any gold-plated leads. Pre-tinning will prove the solderability of the surfaces and will minimize the gold solder contamination. When pre-tinning is not required, leads are first cleaned with solvent. For reflow soldering like this, where no additional solder will be used, new flux must be put on separately. Then a piece of tape is used to temporarily hold the component while soldering. The component is positioned so that each lead is centered over its pad and extends almost to the end of the pad. The procedure is to first solder the leads at opposite corners. Then the other leads are soldered, skipping around to prevent heat from building up. Here a pair of tweezers are being used to provide a light, downward, positive pressure at the upper lead surface. The workpiece indicator is the flow of the solder from the pad up onto the surface of the lead. When the flow is observed, then the iron is removed while maintaining downward pressure until the solder solidifies. After soldering, all traces of flux are removed from the leads with solvent, and the result looks like this. Here are the characteristics of a preferred joint. Notice how each lead is straight, parallel to the pad, and centered on it. Solder has completely wet the full joint. There's unbroken solder coverage over the top of the lead and a continuous fillet along the sides, end, and heel of the lead where it meets the pad. At the heel of the lead, note the height of the fillet. It should be at least 1/3 the total distance between the pad and the horizontal part of the lead. The angle here between the lead and the pad is also important. It should be 60 degrees. Here are a number of unacceptable joints. You have to overdrive these masses with sufficient heat to melt the solder, without at the same time damaging either components or board. These problems are covered in other courses that are available in this series. The next one covers component removal, explaining the limitations of some of the currently used methods, and the advantages of power desoldering with continuous vacuum. This method makes possible the non-destructive removal of any type of component.